Good afternoon, everyone, and welcome to today's live astronomy show. My name is Justin. I'm one of the astronomers here at the Science Museum of Virginia, and I'm happy to be your host for today's show. If you've joined us for previous episodes, welcome back. Always great to have an audience with us for this show. If you haven't watched any of the previous shows, this might be the perfect show to watch. We are gonna kind of slow down the schedule of these virtual shows. It's been so much fun to put these shows together, but we need to spend a little more time focusing on the experiences we're building for you right here in the museum. So I've got today's show. We're going to go ahead and do one in a couple of weeks at the end of May, and then they're going to become a little less common on our schedule. We won't stop them entirely. Still be bringing the latest content to you from time to time, but not following a regular schedule. You just have to watch for those announcements. And I was looking back at things, and the very first content that we put in these virtual shows, I wrote it a year ago today. So that seemed like the perfect excuse to kind of look back over previous shows. Yes, you can watch all 32 of them that are archived here on Facebook. They're on Facebook, or excuse me, they're on YouTube as well. But you can just sit back, relax for the next 20, 30 minutes here. I'm going to do a quick recap of pretty much all the shows we've done over the last year. So it's a clip show, but I've got some exciting updates for you as well. I'm gonna sneak those into today's show. A lot of great content for you. So we'll get started in just a second. Do also need to thank our sponsors for this series, Allianz Partners. Thank you for your support and helping us continue programs like this. Now, during today's show, we're going to be using software very similar to what we use up in the dome here at the museum. It's planetarium software called Digistar 7. They can do some pretty cool stuff, so I recommend using a nice big monitor, opening up the video, and watching it that way for today's show. Let me get us switched over here to that Digistar view. And if you have any questions about the show today, feel free to leave those in the comments as well. Try and address those during the show. Now, if you go and look at the very first virtual show we did for you last May, the very first thing we saw was, well, a view kind of like this. We're up over the Earth, and we visited the International Space Station. Here's a similar view for you. Kind of nighttime where the space station is right now. But if you go back and compare what you're seeing right now to the view from a year ago, if you look carefully, you'll notice that the space station looks a little bit different. I've actually updated the model we're using in this show and our shows up in the dome because of some changes that have taken place on the station itself. It's a good reminder that although the space station has been up there for a long time, in one of our previous shows we talked about how humans have been living on the station continuously for the last 20 years, it's still undergoing renovations and expansions. In fact, later on this year, another module is expected to be added to the Russian segment of the space station, and the US segment is going to get some new solar arrays to help it generate additional energy to power all of the equipment that they've got on board the station. So watch for that in coming months. Another thing that I tried to include in a lot of those earlier shows especially was a potentially surprising fact of the day. And one of those facts that is still surprising to me, I'm never going to forget it, is that well, Mercury, the innermost planet to the sun there, is on average actually the closest planet to the Earth. So as a little view that I used in one of those early shows that keeps track of the positions of the planets over time, and although the three inner planets will be vying for the title of who's closest to Earth most of the time for a little while, if I let it run long enough, it ends up being Mercury the majority of the time. So on average, if somebody asks you what the closest planet to the Earth is, most of the time the answer is going to be Mercury. So that's that's your possibly surprising fact of today as well. I think it's still a pretty amazing little bit of information. In fact, Mercury is usually the closest planet to every other planet in the solar system, which pretty amazing. Now, if you look back just to the last episode, we talked about some of the journeys that our spacecraft take to get from place to place, and so that really puts into perspective. Even though Mercury is usually the closest planet to the Earth, still one is pretty tough to get to. You can look back at the journey of the Bepi-Colombo spacecraft. Speaking of spacecraft, I believe it was the third virtual show we did. We got out to the gas giant planets in our solar system. Ooh, I spent a lot of time talking about Jupiter. I remember that one. That was a long show. But let's distill it down to a couple of simple facts here. I talked about the gas giants, fascinating worlds. I talked about their moons. And at Jupiter, we talked about the Juno spacecraft currently exploring Jupiter. And in just a few weeks, all of those topics will be top of mind at the same time as Juno completes a flyby of Jupiter's largest moon, Ganymede. This is kind of the first big event of Juno's extended mission. Now it's not just studying the planet itself. It's going to get a number of flybys of these large moons and be able to teach us some pretty cool stuff about these worlds. On June 7th, Juno will be closer to Ganymede than any of our spacecraft have been to Jupiter's moons since the Galileo spacecraft flew by the small inner moon Amalthea in 2002. Galileo flyby is actually a fascinating story in its own right. And it was the final flyby of the Galileo mission. But this is just the first of 16 planned flybys by Juno of the three innermost large Galilean moons of Jupiter. So that's something to keep an eye on. The next show we did in sequence, those early shows were kind of a gradual march out from the Earth to the edge of the universe. We had done all the planets in the solar system, so it's time to talk about some of the other worlds out there. So it's time for one of my favorite topics, the asteroid show. One asteroid has been featured in many of our shows over the last year is Bennu. Bennu was the target of the OSIRIS-REx mission. That's what we're seeing here, the spacecraft. Now, after setting a number of records, OSIRIS-REx became the lowest orbiting spacecraft around any object. Bennu became the smallest world to be orbited by one of our spacecraft. OSIRIS-REx made some amazing discoveries, like the fact that Bennu is an active asteroid. Some of the boulders on the surface of Bennu are breaking apart, sending streams of particles up into space. Found that there was water locked up in some of the minerals on Bennu. And then last October, the spacecraft descended down to the surface of the asteroid, grabbed a sample of Bennu. It's going to bring it back to Earth. Last month, it returned to the neighborhood of Bennu to take some pictures. So we actually have now the last pictures the spacecraft is going to be able to take of the asteroid. And here you're seeing the sample collection site. In these annotated versions, the X in the after image marks where OSIRIS-REx set down on the surface of Bennu, and you can see many changes in that region. I kind of dug out its own little crater, shot pressurized gas, nitrogen gas, into the asteroid to churn up some material, and in particular, the team tracked one rather large rock that was thrown out of the larger crater, Nightingale crater, where the spacecraft set down. So the OSIRIS-REx mission has been a fascinating one to follow through this last year. One of the many interesting asteroid stories that I've been able to bring to you. And now, just as of Monday, OSIRIS-REx has fired its thrusters. It is on its way back to the Earth. This fits in kind of well with the long journeys that we talked about last year, last episode. It's going to take OSIRIS-REx a couple of years to get back to Earth. So it has technically departed the neighborhood of Bennu, but it'll make another couple of laps around the sun here. It doesn't drop off the sample it collected until September of 2023. It's just the way the laws of physics have forced us to make the journey back to the Earth. That'll be pretty exciting. So now we've got a little bit of this asteroid that has safely landed on our planet, and scientists here on Earth will be able to study it in some detail and teach us some pretty cool stuff about Bennu in particular and asteroids in general. Let's see. Next in our series of shows, I was on to the outer solar system. There are small worlds out beyond Neptune. I immediately think of Pluto, Eris, Maki Maki, Gong Gong, Haumea, and thousands of other little worlds in the Kuiper Belt. In the months since I introduced perhaps some of you to the Kuiper Belt last year, astronomers have continued to make new discoveries out beyond Neptune, and now, as of just a couple of months ago, there's a new record holder from those distant objects we've observed in the solar system. You've got the few thousand out beyond Neptune. We should get the Kuiper Belt on the screen here momentarily. And let's see, let me add that. Let me add that to the screen for you. And then the latest discovery was found at 132 astronomical units from the sun. If you want to do the math, it's 132 times 93 million miles. Want to figure out that distance, that is 2018 AG37. That's the most distant object that we've seen from the Earth in the solar system. Pretty cool discovery. Now, with all of these planetary and solid objects behind us in our sequence of shows, in another episode, we made the jump to the stars all around us. The closest star to the Earth is certainly the sun, at the center of the solar system there. And my favorite view of the sun from that show was this first light video from the Daniel K. Inouye Solar Telescope. So what the surface of our star actually looks like. The other stars we see in the nighttime sky have similar appearances if you get up close. It's just those other stars are so far away we can't see them in this much detail. That's a reminder that our star and the other stars in the galaxy and the rest of the universe are constantly changing in both small ways and relatively big ones as well. Now, that show about stars also included a brief look at a catalog of stars that were relatively nearby the sun here. The view I gave you in that old show extended out to about 20 parsecs or 66 light years. Recently, a new catalog attempting to include all known objects out to about half that distance, which, oh, I apologize. Looks like maybe the computer isn't super thrilled to show it to you here. Let me see if I can get it on the screen for you here. The new catalog includes over 500 individual objects and over 300 different star systems. Let's see, let me actually get it on the screen for you. I know I was testing some stuff out and don't know where I managed to hide that from you. Let's see, let me try one more place. I don't want you to miss such cool content here. Let's see, let me check one more place for you. There we go. Let's try this one more time. Let's get the new star catalog up there. This utilizes some of the latest data from the Gaia mission that's out there mapping the universe around us right now. So now we can actually see where all those objects are. Again, about 550 individual objects. I believe it's 339 different star systems, if my memory serves me correctly, and a lot of variety in objects here. We see some stars colored yellow in this view, so objects that are sort of similar to our sun. There's some red dwarfs. Those are also stars, but they're much smaller, lower temperature. You may recall that from the previous episodes about stars. And then other things, stellar remnants here, white dwarfs. That's what the sun will eventually become. Brown dwarfs, those are objects that never quite got large enough to shine like stars do. And then any of those green rings you might be able to pick out there, those are planets in orbit around other stars. So that's just a variety of objects that are right here in our cosmic neighborhood. And certainly we could keep going further away, but let's go back to that topic of planets for just a second. Exoplanets, or planets orbiting other stars, were a constant topic of conversation during our shows here. I visited so many different exoplanets, it's hard for me to pick a favorite here to show you in today's clip show. So let's just recall that we found over 4,000 planets around other stars. Now I've switched the circles to a blue color there, but each circle that you see around some distant star represents some other planet that we found elsewhere. But what if we transported all of these exoplanets to our solar system? Well, I've already done it for you once, so let's do it again. Here we're adding all of the orbits of those thousands of other planets to our solar system, and I think the results are pretty amazing. We see that many of the planets we're finding around other stars are very close to their suns. Here around our sun, almost all of the exoplanets we know of, their orbits would fit inside the orbit of Mercury. There are some a little farther from their stars, but those are the minority of planets we found around other stars. A bit of that is because of the way we look for those planets, but it's interesting to see just how different those other planetary systems can be from the group of planets that we know here in our solar system. Now, anytime we start talking about planets going around other stars, that naturally brings up the question of aliens and whether there's life out there somewhere else. Well, with so many possibilities, I would say that, yeah, there's definitely life somewhere. Obviously, some of the planets we've found so far will look very different from any of the worlds we have here in our solar system. So any potential aliens that exist may have to deal with some pretty extreme conditions. So we looked at some of the extreme possibilities right here in our solar system, then at some of those other planets. And one of the things that stood out for me from that first show about exoplanets and alien life, especially considering more recent events, is the Arecibo message. That is one of humanity's attempts to send a message out to the cosmos that maybe some alien intelligence could decode. Now, another topic we covered in another show is the disappointing collapse of the Arecibo Observatory. So I always like to bring it up when I can, remind people of some of the amazing things that the observatory did. So this was something that took place in the mid-1970s, about 46 years ago now. A message was beamed out towards a massive star cluster, and who knows, thanks to the way things are always moving around in space, that star cluster may not even be in the right position to receive the message when it gets out there in a few tens of thousands of years. But this message, if you decode it properly, tells anybody that intercepts it a little bit about us, the number system we use, the chemical building blocks that make us up. You might even be able to recognize a little stick figure down there about 3/4 of the way down. It's a little bit unlikely that anybody ever will pick up this message and decode it. So our ability to send it out into space says as much about us as it does about any aliens that might find it someday. Which is a cool story, and is actually where the message is in space right now. So I think it's kind of cool that we can fly out to that point in the universe. Now, on our march towards the edge of the universe, we also took some time to look through the electromagnetic spectrum and see all of the different kinds of light the universe uses to deliver messages to us. It allowed us to see some familiar objects in different types of light that our eyes can't usually see, but various telescopes and other spacecraft can. There's a nice reminder of that was just released by some astronomers this week. Here's some nice views of Jupiter in 3 different kinds of light. So on the screen now is the familiar visible part of the spectrum that our eyes can see. This is a view collected in ultraviolet light, so out beyond the purple end of our rainbow. That's from the Hubble Space Telescope. And then from the Gemini South Observatory, we've got Jupiter in infrared light as well there. All fascinating views. I think the one in infrared light might be my favorite. Those are longer wavelengths than we can see. I don't know. I'm a little bit partial to those longer wavelengths. Infrared, microwave, radio, those kinds of light can really reveal some amazing things to us. Some of my other favorites, I don't think this made it into any of our Facebook Live shows here, but in our 2020 recap video, talked about the big dusty ring that encircles Saturn. We're familiar with the icy rings in close to the planet. Those are easy to see, even the little telescope here on Earth. You can zoom in on those there. So there's a more familiar view of Saturn. I'll try not to crash. That wouldn't be good. But if we back away here, we see this much larger ring highlighted in red. That is dark dust that we think is lofted off of the surface of one of the moons, named Phoebe, thanks to a micrometeoroid collision. So that's a pretty cool discovery. And then, of course, in longer wavelengths, we can also reveal the whole sky in radio waves, which is pretty stunning. I know that was a highlight of that trip through the electromagnetic spectrum that we made in those early shows. Let's see. So we're on a journey to the edge of the solar system. We did have to take a time out from that sequence of shows to celebrate the launch of 3 spacecraft that made their way to Mars over the last year. Now, there are many things I could say about Mars. We made many return visits to Mars over the subsequent months. Of course, we've got those 3 spacecraft have now successfully arrived. And newsflash, the Chinese mission Tianwen-1, it included a lander which is supposed to land on Mars maybe this evening. So keep an eye out on that. But the highlight of that first Mars show for me was Conspiracy Corner, where I got to delve into some of the less scientific topics that often comes up during shows. But I think there's actually a pretty convincing case to be made that Martians are the reason we explore Mars today. They gave us the motivation and, in a way, the technology we needed to explore Mars. Then you can go back and review that show for all of the details. But an early misunderstanding led to all kinds of speculation about the existence of Martians, and that found its way into science fiction. And that science fiction inspired many people that grew up to be scientists. Perhaps the most notable among them for this story is Robert Goddard, who built the first liquid-fueled rocket, and it's liquid-fueled rockets that got all of the spacecraft to Mars. So without speculation about aliens and life on other planets, we may not be exploring other planets, which I think is pretty cool. So aliens have done at least one amazing thing for us. Let's see, before we leave Conspiracy Corner, let's see what the question is about. Lauren asks, in theory, can something go over or under those red dirt rings? Oh, so back there at Saturn. Yeah, that's a big ring, but it's not very dense. There's not a lot of dust there. So yeah, definitely something could go over, under, even through that ring. The Cassini spacecraft would be a great example. So launched on one of these Martian-inspired liquid fuel rockets, gets out to Saturn, and it flies by the moon Phoebe. So we've actually got some pretty good pictures of it. I could probably do a whole show on that. But yeah, we've had to fly through that ring of material that comes from Phoebe to collect the pictures that it did. So yeah, thanks, Lauren, for that question. Definitely, you go over, under, even through thin, dusty rings like that one. So there we go. There's Conspiracy Corner. I had a lot of fun with that one. So at that point in our sequence of shows, we'd pretty much seen a little bit of everything. So we were ready to get to the edge of the universe, and I'll go ahead and do that for you in this show as well. To help us out, remind us of other things that didn't make the cut for this whirlwind review of our journey through the universe. Here's another interesting item that was in one of those old shows. This is something called the Exotica Catalog. It was actually put together by some scientists working on the search for extraterrestrial intelligence, or SETI. And what they wanted to do was make sure that we understood all the natural things that are found in the universe. So if we find something that seems unusual to us, can we be sure that's not just a strange example of a planet, or a strange example of a star, or a strange example of a galaxy? So they went through everything that we know of, found the most mundane and the most unusual examples of every kind of object out there, made an exhaustive list of those objects, and put them all on one website that anyone can take a look at. So here's our map of this Exotica catalog, a little bit of everything the universe has to offer. And look at all those things that we could talk about. Every different object there could probably be its own show as well. So there's no shortage of content for us. But let's get rid of some of those labels here that kind of clutter up the screen. And we are finally going to get to the edge of the universe in today's show as well. All the stars in the galaxy, all the galaxies outside of the Milky Way, some big gaps in our view here, just where dust in our own galaxy gets in the way. And then finally, the very edge of the observable universe. So there's our whole universe as we know it today. Our knowledge always changing, always new objects to discover out there. We'll always have more discoveries to bring to you in future shows. Perhaps another surprising fact of the day is that everything you're seeing on the screen now is just a tiny fraction of what the universe is. The more we learn about the universe, the more we become convinced that there are things we can't detect directly. The planets, the moons, asteroids, comets, stars, galaxies, gas clouds, dust rings, that's all normal matter, baryonic matter, as a scientist might say. It's about 5% of the entire universe. Most of the universe is dark matter, dark energy. We've got lots of evidence that's out there, but your first question is probably going to be, okay, so what is it? The answer is, we don't know yet. So we're still trying to figure that out. That might be the biggest surprise about the entire universe, just how much there is left for us to discover. So after getting through the entire universe, we still had more to talk about, because there are so many things happening, so many new things being learned all of the time. Of course, other shows have talked about specific, say, exoplanet discoveries. We talked about some big anniversaries. We talked about various spacecraft missions to explore the solar system. Kept you up to date on the testing of new rockets, NASA's commercial crew efforts. I'm just rattling off some of the things that I see on the calendar here. Man, I'm never going to forget the sample return mission show, where we talked about a little bit about OSIRIS-REx and some of the other things like Hayabusa 2, some of the historical missions, and our phrase of the day, tiny particles. Oh, that was the best. Oh yeah, got to play my favorite game of astronomical speculation back in January. Will it happen? Where kind of looked forward through the entire year to see some of the things that we might have to look forward to. Some of those things have happened. We're still waiting on a few things, like the completion of the Vera Rubin Observatory down in Chile. This telescope, once complete, hopefully will start taking its first test images later on this year. It will, over the next decade, take a 10-year long time-lapse video of the universe, which is pretty amazing. It'll yield some unique discoveries. Also enabling some unique discoveries is the James Webb Space Telescope, or JWST. Its launch is still technically scheduled for later on this year. Just announced this week, the telescope has completed its final deployment tests. It's all ready to be folded up, put on top of its rocket. After so many delays in the program, oddly enough, now they're worried about the rocket being ready, now that the telescope is all ready. So stay tuned. Scheduled for launch on Halloween as I speak right now, but that could change literally any day. Another big launch we're still waiting for. I've shown you some of the tests of the core stage of the SLS rocket earlier this year. It may launch as early as November. Well, we'll just have to wait and see. It would be the Artemis 1 mission, the first launch of NASA's new SLS rocket. If it does launch this year, it'll take an uncrewed Orion capsule around the moon, paving the way for astronauts to head that way in the not too distant future. And Artemis 1 here will have some other scientific satellites on board as well, some bound for the moon, some for more distant destinations. So still a lot to see coming up later on this year. We've seen some amazing things in 2021 already. I mentioned that later tonight, perhaps another Mars landing. It looks like people tracking the spacecraft do see signs that Tianwen-1 has adjusted its orbit to release the landing capsule. Once that's released, there's no turning back. They'll be attempting a landing on Mars. We don't have a lot of official information. That's just the way the Chinese Space Agency works. But if they do land tonight, we'll certainly have updates for you. Keep an eye on the internet. We'll see what happens. And then as for our shows, remember, we will be back with you in a couple of weeks. So our last regularly scheduled live astronomy show for the foreseeable future here, coming up on May 28th. And I want to do something a little bit different for that show. I always encourage you to add questions in the comments if you've got them. I'll certainly answer them during the shows if I can. For that show on the 28th, what I'd really like to do is build it around your questions and requests. So maybe, despite all the shows we've done, all the ground we've covered, maybe there's some corner of the universe that you think we haven't covered in enough detail yet. Maybe your favorite planet hasn't gotten enough airtime. Maybe you've got some question that you just haven't asked yet. Well, now is the time to ask it. If you have anything that you want to see in the show on May 28th, please leave that in the comments below. We'll be keeping an eye on those. And if time allows, we'll get a reminder post out to you as well. We'll collect as many questions and comments from you as we can, and we'll use those to build the show for May 28th. So I hope you can join me again in 2 weeks. It'll be same time, same place, 3:30 p.m. Eastern Time. And let's see where your requests take us before we get into summer break. Should be pretty fun. So until next time, be safe out there. Thanks for joining me for today's show, and I hope to see you again on the 28th.